Okay, here's a particular kind of problem that comes up quite a lot, so it's worth learning as a set piece. I've got a point, I've got a circle, I want the length of the tangent, not the equation of a tangent, a length of a tangent, okay? And this point is not on the circle. In fact, we hope it's somewhere outside the circle. So what's going on here is we've got a circle and we've got a point not on the circle. I'm not trying to draw this accurately, I'm just showing the principle of what's going on. And we want, if we imagine a tangent through that point drawn to the circle, okay, I could actually draw it in two ways, but these two lengths are actually the same. So I can get rid of the top one. I can just think about the length of this line from the given point to where it forms a tangent with the circle. And the other point I need to show on the diagram turns out to be the centre of the circle, because then if I join everything to the centre, which is always a good trick in a circle question, I can see this is a right angle, so I have a right angle triangle. So I know this is the point 28. Okay. The other point that I can work out easily are the coordinates of the centre of the circle. Okay. I need to do something with this equation before I can do that. But when I know the position of the centre of the circle, I also can work out the radius of the circle, r. So if I've got the centre and radius of the circle, then I can find the length using 2 points. I can find the length of the hypotenuse. I know the length of one of the other sides once I know the radius, and that's how I'll work out this. I can use Pythagoras in this triangle. So that's my big plan. But I need these two pieces of information, the centre and the radius of the circle first, and this particular circle is given in this form. So my first job is to write this in the other form where I can read off the centre and the radius. So I'm going to take each of these three coloured underlined parts in turn. So for the first one, x squared plus 4x, I need a squared bracket of x plus 2 squared, and I need to take away 2 squared, which is minus 4. So that's the first part. Then the next part, the y squared minus 10y is y minus 5 in a bracket squared, and minus 5 squared is 25, so I need to take that away. So there's my blue part. And then easiest of all, I mustn't forget the plus 20, which is the bit in red, and I mustn't forget the equals naught either. So here's the equation of the circle in a more friendly way. So for the first part, I'm going to have x plus 2 squared, and then I'm going to go to y minus 5 squared, because this is how I like the equation of my circle to look. And then I've got minus 4 minus 25, which is minus 29, plus 20 is minus 9, equals naught. But then I can add 9 to both sides of the circle, so I'll be very lazy and just do equals 9. So I can see that the centre of the circle is the point minus 2 and plus 5, and the radius don't forget to square root, so the radius is the square root of 9, which is 3. Okay, so in my diagram I now know this is the point minus 2, 5, and the radius here is 3. And so in the diagram I know this distance here. I want to know this one here, so I've got to work out the length of the hypotenuse. So the hypotenuse of the triangle is, or I could call it the distance CP if I want to give these points names. So you'll sometimes see it written using the name of 2 points. But it's just the distance method for 2 points. So it's the difference in x squared plus the difference in y squared added together and square rooted. So if I look at my two sets of coordinates, the difference in x, I'm going to do 2 take away minus 2, that's 2 plus 2, and I'm going to do 8 take away 5. So 4 squared is 16, 3 squared is 9, so this is the square root of 16 plus 9, which is the square root of 25, which is 5. So my hypotenuse of the right angle triangle is 5. This is going to work out lovely. So I've now got a right angle triangle, and the distance, if I call this point x, I want the point px. So in the right angle triangle, px squared plus 3 squared is going to equal my 5 squared. Okay, now you probably recognise these numbers, but let's show you the full method, just in case you couldn't just write down the answer to px. So it's going to be, this is 25. I'm taking away my 3 squared, which is 9, so px squared is 16. So px is the square root of 16, which is 4. Notice that I don't need plus or minus because it's a distance, and distances can't be negative, so it's 4 units. Now, very often you'll get a surd here rather than the answer being an exact square root. But there's your method for finding the length of a tangent.